Hello and welcome. Ooh, what's going on with that? Sorry, slight little issue. I think I've got myself open in another window, which is going to be annoying. Which one is it in? Let's just close down all of the YouTubes. There we go. Found you. Found you. Fantastic. Right, I am back. I am back with you. I apologize for that one. I seemed to have an echo then. So what are we doing today? We are going to go through and build a new dev tool that I've been working on kind of the last couple of days. I've got this issue where I've got my desktop computer in my office and it's fantastic. It got it through work. It is a Mac Studio. It's fast. It's amazing. And I set up my environment on it and it's perfect. Then I've got my MacBook Air that I use when I'm not in my office, when I want to just kind of sit on the sofa and kind of hack on an idea. And I set that environment up. And what I've found is that sometimes I'm on my laptop, sometimes I'm on my desktop. I start, tweaking my dot files, and then I go to the other machine and forget to work with it, or I install a new brew package or app and I forget to install it, or it just gets, we start with this perfect state of great, my environments are set up. And then we work on each one and they occasionally get out of sync and it starts to get a little bit rubbish, if I'm honest. So what I wanted to do was build a service that will allow me to kind of keep my environments in sync. I don't know if anyone else experiences this, but it's a real issue for me where I find a cool tool. Like I found one this morning. It's on my desktop now. It's not on my laptop. Am I going to remember later tonight? Am I going to be too busy to remember it? And it's going to be great to use. I'm going to love it. But I hope I remember later. I could set a reminder or I could set a to-do task. But that's just adding on to all the other things that we have to remember, have to kind of manage and maintain. It just starts to get just horrible. So I thought, how can I get around this kind of pain that I'm feeling in as lazy a way as possible? Because we all want to be lazy sometimes. And I've come up with an approach. Let me share my screen. And here we go. So here's my laptop, here's my desktop, and I've created something called Envy. And what it is, it's basically just an environment sync. Environments. So there's going to be an API. It's API only. There's no front end needed. It's literally cool. Sign up to the CLI, register my device, start syncing my information, go to my other machine, sync that as well, and start to keep things kind of just moving, really. That's the plan. So that's what I'm going to do. What we're working on today is the API side. I've started some of the kind of the CLI aspect, but I've still got a couple of ideas I want to kind of polish off screen around how it could work. So we're going to focus on the API side now. So what I'm going to do, we're just going to dive in. I'm sure you've seen my beard before, so we're going to hide that out of the way. And we're just going to go straight into our editor. So PHP Storm, I'm using Laravel Herd. I've got an application ready. If we go over to here, I can come over to envy.test and my service is online. It is all good. So what we've got is our roots here. Let me just zoom in. So we've got a URI, which just literally returns a new message response. This message response comes from a package I created at work called Laravel API responses, and it just makes my life so much easier. Instead of having to keep creating the same sorts of responses over and over again for my APIs, I can just pull this in, and then I've got somewhat scaffolded way to send responses as an API. If I need to go further than that, I can create my own. Hello to everyone in the chat. Thank you for joining me. It is awesome to see you here. Let's dive in. So how does this work? Well, I've got my database set up. I'll go through the models. It all starts with a user, obviously. Everything starts with a user. We have our user model, and they are able to register devices. Here is a device. From a device, we're going to get the name, the type of device, the operating system, the architecture, the identifier, whether it is the default device or not. So the problem with these sorts of applications is that if you want to keep syncing things, which is your source of truth? Is your desktop the source of truth, or is your laptop the source of truth in my case? And then we've got the user ID and the synced at. When was this device last synced? So the idea for that is like the CLI script can, ping the API and say, okay, when was I last synced? Cool. It was, 3 days ago. Show a notice saying, perform a sync to stay up to date or something. Yeah, I haven't really thought that part out yet. But there's that. And then this can have many shell configurations. So a shell configuration is basically, your ZSH shell could be your bash shell, could be any number of shells, really. For me, it is ZSH. I use Warp, but I kind of use it through ZSH. And on top of that, I've got power level 10K. So my shell works for me the way that I like it to. So what I'm going to do is we can register a shell. It's got a name. This will be, things like ZSH or Bash or any number of any other shells that you might choose to use. Maybe you've got a custom one that you use that works for you. Absolutely fine. So then the shell config, basically we just take like this ZSH configuration and we add it to data. Then on the CLI side, when we're syncing, we're going to say, okay, so give me this, give me the shell configuration for the device. Great. Write it file, job's done. Restart the console session, and you're good to go. This is tied to each device, so you can maintain separate shells. But what I'm going to do is, allow you to say, okay, just copy from my other device, or copy from this device, or something like that. We'll get into that more as we get closer to it, I think. Then we've got Mac apps. Currently, this isn't attached to a user yet, or a device yet, but it will be. So that'll be things like, maybe PHP Storm. I've got Chrome, or I've got Safari. I've got this, and all of these things we can get from our OS, which is why we need to kind of Golang later on. Again, through packages, we can just kind of get the name, description, and meta information. Now, Homebrew actually has an API that we can get some stuff from to kind of backfill the information, which is why we've got a meta property. The idea there is that we're going to pull in some information from the Homebrew API for each package so that you can, if you want to kind of have a quick look at what might be going on, you can kind of see that. Editors, again, this is like, maybe you've got VS Code, you're using Vim, NVim, PHP Storm. There's another one I started using. I can't remember what it's called. So this is, what is it called? I can't remember what it's called. See, I haven't got it installed on this computer. Proves my point. I forget things. Okay, then we've got, what else have we got? Through packages, shell configs, shells, Mac apps, and shell. And that's all that we've got so far, really. So as far as I've got, we're going to go a little bit further. We're going to start saying, okay, so this device has got this editor, it's got this, it's got that. perhaps device is going to expand a little bit more so that we can add like, shell config ID. It's got this, we'll look at that. But the idea is that each device can have multiple editors. It's going to have multiple brew packages and multiple Mac apps. It's going to could have multiple shells where you want to keep the configuration. So we're going to start linking all that up later. But I thought we'd start by doing like the simple stuff, like let's register my device and that sort of thing. So let's dive in. What I'm going to do, I'm going to close all the other tabs and we're going to look in here. So we've got a way to look at apps, got a way to do authentication, our devices, packages, and shells. So packages are brew packages, apps are Mac apps. This is obviously aimed at Mac because I use Mac for any kind of code stuff that I do. I will open source this, of course, as I always do. If you use something else, then feel free to kind of add a PR. Maybe you want to add Windows support, PRs will be open. So what we're going to start with, we're going to start here with devices. And what we want to do is have a way to register a device. So to come down to roots, devices, I've got nothing in here. I've added my to-dos of everything that I need to do. That's do here. We are good to start. So zoom in and let's focus on what we're doing. So we've already prefixed at this point. So what we're going to do is we are going to do a post request here to register. So this is where we want to register a new device. We will need to create a controller for this. So let's go and create that. Devices. Create a register controller. Hello, hello. Thank you for joining me. So what we need to do is we need to accept a request. So what I'm going to do, I'm going to drop in the invoke function. We'll add the request in a minute because we're going to want to probably do some form validation on that one in reality. So we validate our request. Then we want to dispatch a job to register device for the user and return a response. That's kind of my approach to APIs typically is, okay, once we've validated, let's push this off to the background because the way that it works isn't super important. So let's look at validation. We'll go make a request, devices, register request. Now, some might argue that this should just be a post request to slash devices because we're just creating a new device, but I want it to be a little bit more deliberate. I want the API to kind of reflect more what's going on. So devices and requests. That is that part. So now we can come over here and we can just say register controller, this one, class. And what we're going to do is we're going to pull in this namespace. The reason I'm pulling in this namespace is because then I don't have to import every single controller. I can just say devices, then the name. We're importing the namespace, not the class itself. Keeps it a little bit cleaner. If it's zoomed in too much, please do let me know. I can zoom back out. I'm trying to make sure that it's good quality that you can see. So validate. We can remove that because we're going to do that in a different class. Let's go ahead and start this. So let's declare our strict types. We're not going to extend this, so we can make this final. Determine if the user is authorized. Well, that is true by default, so we can remove that. And we can focus on the rules. So what is a payload that we are going to expect to have sent? If we open up our device, we're going to want to get the name, type, OS, architecture, and identifier. Default or not. I think when you register a device, it'll become your default. So we're going to grab all of those in the register request. So our name, this is required. It should be a string, minimum characters of 2 with a maximum characters of 255. Hello, thank you for joining me. Type, so this is again required, should be a string, minimum characters of 2 and a maximum characters of 255. OS is required, string, min2, max 255. Architecture, again, is required. The biggest thing here is that everything's a string, basically. Yeah, I don't usually like to do everything as a string, but in this situation, it makes sense. Identifier. Now, identifier is a funny one. Like, there's so many different ways that you can identify a device, but as long as the CLI is doing the identification in a persistent way, it's absolutely fine in my eyes. So architecture, identifier, OS for the operating system, type, and name. So what I'm expecting here from a payload is, my name is going to be something like, something at localhost maybe. The type, the machine I'm currently on, it'll probably just come through as a Mac Studio. The OS, it'll most likely come through as Darwin or other. The architecture will come through as ARM2. And the identifier will come through as some sort of UUID, most likely. So that's kind of what I'm expecting here. We know what the host name is. We know what type of device it is. We know what operating system they're on. When you do an update and it does a sync, it'll update this. The architecture that you're on, that's not likely to change, but it's useful information to know. And then the identifier. So what you're able to do is you can then look at things like Mac apps and you're like, okay, so my Mac Studio, for example, is an ARM2 device on this version of the operating system. I want to install this other Mac app, which isn't supported on these, so I can't. So there's, we can look at doing some checks around that. So that's that part. And what we're going to want to do, or what I like to do here, is create a payload from that information. So we'll just create payloads, and we're just going to create a new device payload. What this is going to have, this is basically just a DTO. I call it a payload because it's coming from the HTTP layer. That is the only reason. So I'm just going to say private read-only string name, private read-only string type. And we're going to have a read-only string OS, a read-only property for the architecture. Go back and double check. Then just identifier. So private read-only string identifier. Finally, private read-only bool default, which is going to default to string. So we want a way to save this in the database. Public function to array. How does this look when we send it to the database? Is there any transforming that we need to do? At this stage, no, it is somewhat simple. So now we can just add all of this in. Say, this OS. That OS architecture identifier, this identifier default, this default. Nice and easy, straightforward. Final method is how we want to create it. Public static function from request. You're going to get an array of data coming through, and we're going to return a new request, new device there. Return a new device, new device. That's going to get weird to type. And from there, we can work with the data. So in the interest of static analysis, we're going to use an array shape. So we're going to get a name coming through, which is a string, a type, which is a string, an OS, again, a string, architecture, string, identifier, also a string. Then I always type string wrong. I don't know why. And then finally, default could be null or Boolean. So our name for the device will be data name. And that's the best bit about using like an array shape here, is that we can match properties up to what is in the array. Then we can get OS, data. What am I doing? My typing is just off today. I've had a week off work, so I do apologize if my typing is not quite there today. I've not properly typed for a whole week while I was away. Spend it with the kids, which was great. Although they got a little bit ill, which is never good. Right, okay, then default, which is data default. If we don't pass default, we're assuming true. That is my approach here. Which color scheme am I using? That is a good question. Standard light with header, to be honest. Yeah. It just works for me. I like light themes. Right, so what we've got is we've got a new device here. So on our request, we're going to add a public function payload. It's going to return a new device. So we can return new device from request. And what we've got here, when we're passing through the data, we know we need to pass through a name. So we can say this string name to string. We've just validated that above, so we know what we're doing there. What I'm going to do, I'm just going to copy that. Then we've got the type. We can replace that for type. Jump the gun a little bit there. But OS is going to be in there, not iOS. You're worried if you try to sync your iOS device. Architecture is going to be architecture. One thing I never understood is why people use really short names all the time. Like, why? Did you, do you need to really worry about that? Minimum characters as possible. Right, identifier there. And what we're going to do is default is going to be this has default. If it has default, we're going to pass through this Boolean default. Otherwise, we're just going to pass through null and let it carry on. Yep, completely built in. So there's our payload, which means that in our register controller itself, we haven't had to do any logic. It can just be straight in the request because that's what it's tied to. You want to get an object from your request, and that's the easiest way that I found to do it. It's a little bit long-handed, but it works really well for how I write code. Next, we're going to want a background job. So make a job, devices, register new device for user. Descriptive as you can be. That's the best way that I found to do anything to do with like background jobs and stuff. Just be as descriptive as you can. So we want to dispatch a new register new device for user, which means I'm going to need the user itself. I'm going to need some record of the user. So what I need to make sure that I do is anything in devices, packages, not auth, that's shell, sorry. That's my bad. So we're going to have to split this into two. So we're going to have authenticated routes. Root, middleware, we're just going to say auth sanctum, because we're going to use sanctum because it's going to be so much easier. And then we're just going to group here. This will be a static function that doesn't return anything. So we can get everything that we want in there. So it's going to grab all of them for now. Drop them in there. Come back up. Don't need to be authenticated to choose your auth routes. So I can move that out. So now that's registered the middleware. I don't need to do anything specific in here. In my controller here, I know I'm going to get that user. So I can say public function construct. In my constructor, this is my preferred way of getting like the user. Typically, you don't actually need the user. You just want the user identifier. So I can say private read-only authenticatable. I'm going to get that through as auth. So then I can just make that a read-only class. This is my job. So let me clean this up. There's some strict types. Make this final. I'd usually publish with stubs, but the problem with publishing stubs when you're doing a live stream is that you end up, skipping the changes that you're making, and then you don't see the difference. You wonder why your code looks different. I've published my stubs. What did I do? Why did I do it? I can walk you through it this way. So first thing I'm going to accept is a read-only string for the user. Then a public read-only new device for the device. Then I need to execute the job. So over here, I need to pass through the user. This auth, get auth identifier. That won't go through as a string, it will go through as mixed, but it's okay for now. And the device is request, payload, done. I've dispatched a job now, so I can register it for the user. One thing that I haven't done is identifier. Well, we kind of want this to be unique, right? We don't want to be able to register the same device multiple times. So we're going to say we want this to be unique on devices for the identifier. Because when we're registering, we don't want to register the same device multiple times. We'll go this way. It works. So we've now sorted that out. This will do that. And what we're going to want to do here is say, okay, let's return a new message response. We can then come up here and we can say, we're going to return a message response. The message that is going to be is, we are processing your request. The status we want to pass through is status accepted. And that's it. We want to be able to send a post request to here, and it's all good. What I'm going to do for now is remove that because I haven't finished all the authentication, and we're going to test it. So let's create a new request. We're going to go to http nv.test devices register. Method not allowed. Fantastic. Let's switch that over to a post request. Target class does not exist. That's because authentication isn't there. Okay, so what I'm going to do is undo that. Come over to here. Let's make sure everything is migrated. Why is it failing? Connection refused. Okay, so I need to come down to env, make sure my env is done. I'm going to use SQLite. Comment that out because it's not needed. Try again. Yes, I'd like to create it, and there we go. So ADB seed, that should create a user. So I can now go to a tinker. I can double check this. Have I registered myself? Yes, I have. So user equals app models user. Let's just grab the first one. So now I can say user create token where the name is test. Here's my plain text token. Let me zoom a little bit. Is it going to give it me? It's not going to give it me. Damn it. That is going to be a pain. Let's see what happens. Why is my Zoom not working? Appearance. Editor font. Scroll somewhere. Scroll appearance. Where is it? Maybe some font. Use custom font. Appearance. Edit tabs. Oh, I can never remember where this is. I swear it should be working by default. There we go. I was using the wrong thing. All right, a tinker, user, create a new token. Here's my plain text token. So I can now grab this and I can use it. So there's my token. What I'm going to do is go to auth, bearer token, and send it again. Service online. Great. It's redirecting for some reason. We're doing it posted there, blah, blah, blah. Headers. Accept. Application JSON. Send it again. And now we're good. What are we building today? We are building a dev tool to basically allow me to sync my dot files in a nicer way. Like dot files are great to get started, but they're not perfect. That's what I found, is they're just really not perfect. What app are you using to test the API? This is actually HTTP. So you're probably used to seeing something like, can I zoom in? No, not easily. Let me come over to here. Like, let me close that. You usually used to use it using HTTP there, and it's great. There's actually a desktop app that I found today, which is really handy. Authors on, it's that. We can go to the body, and we're going to have text. So we want our name, device name, Steve's machine. The type is a quantum teapot. The OS is going to be PG tips. I'm British, I'm using T puns. The architecture for my PG tips machine is going to be pyramid, of course. And the identifier is going to be PG123. Bam, we're processing your request. So what I'm going to do, I am going to now go and rename and move. We're going to create a new collection, and I'm going to call this Envy. I'm going to add that icon, and I'm going to give it that color because it's cool. Now I'm going to name it register device. So this one up here is something I created earlier today, a little Go script that will allow me to like have my own kind of like request bin style thing. Long story. So we're processing your request. Send it again. Processing your request. It's not been registered yet. So let's come over and focus on this part here. So what we want to do here is actually register a device for a user. There's so many different ways we can do this. We can do it inline. We can use an action class. We can use a command class, which I've used before, service class, repository. There's so many different ways. Is there a way you would like to see today? I'm going to ask the people watching and just see what people want to see. You know, do you want to see clean code? Do you want to just see it get done? Yeah, either way, it's going to be fun. That's the main thing, right? Coding along. If you are coding along, I tip my hat to you, or as a British we used to say, I doff my cap to you. Not sure if anyone's going to reply, so I am going to go for clean. So let's say we've got services here. We're going to have a device service within here. Here's my device service. What we're also going to have is repositories. And inside my repository, I'm going to have a device repository. So what the device repository is going to get in the constructor is the database manager. So we can say private read-only database manager as database. Perfect. Then our device service, what this is going to get inside of it, inside the constructor, is going to be our repository that we want to use. So private read-only device repository as repository. So typically what we'll do in kind of like a clean code scenario is that our controller or our job, yeah, PHP 8 isn't, read-only is a PHP 8 thing. Like if I just quickly swap my PHP version to PHP 8.1, for example, only allowed since 8.2. So because I use 8.2, I'm able to use them, which is great. So I've got my repository and I've got my service. So in my service, what I'm going to want to do is say public function. I just want to register a device here. So this is going to call the repository to register the device. So what we're going to want in here is public function create. We are creating a new device. Contextually, when it comes to a repository, you are creating something at that point. And what this will accept is an array of attributes. And we're going to return this database transaction. The callback is going to be, for now, I'm just going to use the model, but you could say like, I don't know, this database table devices insert, but I'm not going to do that. I am still going to use Eloquent because why would I use Laravel if I'm not going to use Eloquent really? Query create as attributes is attributes. I'm going to attempt it twice, and if it fails, it fails. So this will return a model, which is likely going to be a device. I will add my dot blocks because that could throw an exception if the transaction fails for a specific reason, which, you know, maybe I'm failing at this point. Now on my device service, what I want to do is I want to take in the user and new device as device. And what I want to do is return that model for the device. So what I want to do is return this repository create. Now the attributes is going to be an array. We're going to have the device and the user ID. Wait, sorry, my bad. To array. There we go. And that's it. Now this again could throw an exception, which is absolutely fine, because we want to catch that within our job itself. So register new device for user. What we want to pull into here is the device service. We want to try, say, service register. I'm going to pass through the user, and the device, we're just going to pass that through too. Catch throwable exception. And what we would do then is throw a contextual exception. So we can say a make exception devices failed to create device. Done. So over here, we could just throw a new failed to create device. Now the message will just be exception get message. This is for internal use after all. And the previous will be the exception. That's all we need to do. And we're relatively clean here. So if I come over to here, just make sure it's all working. Yep, all good. You declare that as strict types. We'll make this final because we're not actually going to extend it. So that will create a device. This is accepting our request. That is talking to our repository. Our repository is actually doing the action of creating a device in the database transaction. Our payload is working. Our model is good. Our endpoint is good. Let's test it. Processing your device. So now, if I come over to here, say a Tinker app, models, device, first. There we go. Steve's machine, quantum T-bot, PG tips. Awesome. Now, if I try and send that request again, I should get a failure. Here we go. The identifier has already been taken, which is great because it means that in my CLI, I can't re-register the device. It's going to come back and say, whoa, slow down a minute, you've registered here. And it's all good. And so we can register a device, which is perfect. What we want to do next is look at, I suppose, listing our devices. Maybe we don't really care about listing our devices. We only ever want to, like, right now, my focus is just getting things writing and syncing. Later on, I'll add that sort of stuff. So what could be next? Device register controller, blah, blah, blah. That's all good. I'll handle auth later. I'll tell you what, let's take a quick detour to Golang. So this is something else. What I'm going to do is just to stop running that, so I don't actually need it. And what we're going to do is we are going to open up MV. So here is MV. Let me just close all of these tabs and let me walk you through what MV does. It's a Go package thing, a Go module, sorry. Oh, I've registered under just Steve King MV. It's got a command namespace, which is here, and that just calls execute on the root command. So go to our root command. This is a Cobra application. So what I can do is I can just come here and we can say go run main.go. And it does nothing. It just empties. It is just empty. I think it might be because there's an error somewhere. But what it'll do, it'll just say, MV allows MV, the CLI app, to help keep your devices in sync. Then a longer description, the version, by default, it's returning nil. And when we execute, we're just saying that. The init command is ran before anything else in here. So when executes are going to be called, it will call init to see if it needs to kind of do anything in advance. This is typically where you'd load in environment variables or config or anything like that. Then from there, what it will do is we can have like the init command itself. What init does, it initializes the MV CLI. So we get our home directory, which comes from a Go module called Go home dir by this person. And if we fail, we format an error and we throw an exit code. So what we can do is just show that one. Init, bang. So if I just cat out my MV config, I've already got that. But if I rm minus rf, I remember how I do that part, MV, there we go. Now if I try and cat, it doesn't exist. Run it again, failed to load config from mv.json. Now, the reason this is happening is because I'm trying to load config in another command somewhere. I think in register, maybe. Init, command, add this part here. So if I just comment that out, run it again, still failing. Another command must be trying to do the same thing. Config probably, yes. Okay, so I just need the one init command apparently. Cool. I am learning Go as I go. So now if I cat again, my config is there and is ready. So the idea here is that you will install, you'll run init, you'll add your API key. It will write it to the database. Write it to config because it's in your local user command directory, nice and safe. And then it will go ahead and do other stuff. So what we've got here in it, what's dying, something's underlined red. What's wrong with this? Unresolved reference new, config new. That's weird. That's config. Okay, I'll walk you through that code now. Okay, so in my package itself, let me fix the appearance on this to be a little bit bigger so you can kind of see what I'm doing. So I've got command, I've got package, inside package, I've got storage, device, config, and client. So let's go for storage. This is a little wrapper that I've created that kind of wraps working with the file system a little bit in Go. So it's aimed to be fluent a little bit like Laravel, so it's familiar to me. So we've got our struct, which is just the file system. We pass it a path, and then we're saying we want to work with this path. We want to create a new one. So we say just new. This will return a new struct and allow us to work with that. And then set the path. So this allows us to do like, file system dot path string, for example. And then that gives us a file system back to then we can just say, does it exist? It's a little bit fluent, the way that I'm used to doing things. So then we can set the path. So we're saying, at this point, we're going to be able to configure which path we want to send it to, home directory .mv/config.json. Does it exist? No. Cool. Create it. So then we've got a creator. So we can create like the mv config. We've got 2 usages of that at the minute. In config, apparently. I need to go through and clean up some of this. Then we've got read. So maybe we want to. Nah. Okay. Then we want to read. So we want to read a file, and then we want to pass it in and basically say, okay, just read this information and give me it back as an interface. Like we could pass through a struct there, but right now I'm not. That's just going to give me a default interface to work with, basically, to then allow me to access the information on it, to add it to a different thing. Yeah, it's Go. I'm not 100% with Go yet. And then obviously we want to be able to write data. So we pass it through some data and the file mode, the permissions, basically. And that's it. That's writing things to storage. Then our config at the minute is super simple. At the minute, all I'm storing is the API key. It will expand as time goes on, where I want to store additional things in config. So again, we create a new one, very similar pattern. We want to add a key. I'm just adding a little helper method to add the API key. Then we want to register our config. So what we're doing is we're going through and we're saying, okay, create a new file system storage. And what we want to do at the path that we passed in, we want to make sure that the directory is created. And then we want to write our config within that directory. So what write would do, again, create new storage. Can we create it? Then if we failed, then we failed to write config to file, basically. Ooh, did I just do something? No. When we load, what we're going to do is we're going to say, give me a file path. I'm going to try and open it. Fail if we error. Then we want to defer closing that file, basically, is what we're saying here. It's wrapped in a little kind of function to say, okay, defer the closing of this, but if you fail to close it, basically just error out. Then we're going to get a JSON decoder, and then we're just going to decode that JSON. Basically, this part isn't completely written. This is something that I'm working on. Our HTTP client is somewhat relatively simple. We've got auth URL and a HTTP client from Golang by default. So we will say, okay, let's create a new. We're going to create a new request. Basically, what we're saying. So we say, HTTP to an endpoint, and then we want to do a GET request, for example. So on that HTTP struct, we're going to say, okay, so if we don't have an auth key set yet, we're just going to error out and say, I don't want to send an unauthorized request, and just exit. If we do have an auth key, then create a new request, a GET request to the configured URL, and just null the body. This, the way that it should be called is HTTP to GET. Relatively simple kind of API to work with there. If that fails to create the request, then error out. Then we're going to set the authorization header to the API key that's set on our HTTP client. And then we're just going to return doing the request, which is either going to return a response or an error in this case. Again, same sort of thing with post request. Can't send an unauthorized request. We're going to create the body. We're going to get that interface. We're going to marshal it into JSON. And then when we send the request, we're going to send it as a buffer of bytes in effect. If error there, I don't know why I'm doing that twice. Again, set the authorization header and then do the request itself. The final thing that I'm doing in Go at the moment is the device itself. So we create the struct. I'm going to zoom in so we can really focus in on this because this is quite an interesting one. So name, type, OS, architecture, identifier, similar to what we just did in PHP, right? So we want to create a new device, similar to how we're doing all of our things. Then we want to set it up. So we want to get our device, we want to set the name, then the type, then the OS, the architecture, and the identifier. Finally, we want to return our device. So setting the name, we want to say, okay, using the OS package, give me the host name. If we fail for any error, for any reason, bail out and say, couldn't get the host name, close the app. Because at that point, we want to look at why aren't we able to get the host name? I've tested this locally, it's working. However, it might be an unsupported operating system. It could be unsupported something. Many reasons. If we do get the host name, then we just want to set the name of our device to the host name. The type, we want to try and get the model. Now, this is a separate call because it's quite long. So we want to execute a command on our system profiler to get the SP hardware data type. Long, I know. So we want to get the output and the error from the command. And if we error, we want to fail out, basically, and just say, okay, cool. So give an empty string and an error back because we bailed. Passing the output to extract the model name. Okay, so we want to loop over each line within the output. And if the string contains the model name, we want to split it at that point, trim the space, and just get the first part if the length's longer than like one. And then finally return that. Otherwise, we're just going to kind of return an empty string and format error F, model name not found. Couldn't find it. Sorry. Let's zoom back up. So then we can just set the model. So locally that'll give me something like Mac Studio. So OS, we're just going to get the runtime Go OS, nice and simple. Same with architecture, runtime Go Arch. Runtime is actually a really cool package to use for this sort of thing. Identifier, get identifier. This time we're going to use a different command called ioreg. We're going to get the information from the IO platform expert device. So this might fail. And what we're going to do is let's just have a look at what happens if we run this. So I don't know if I've not tested running this locally. So if I do ioreg minus rd1 minus c, and I'm just going to grab that and drop that in, it will give me lots of information about my device. It's great. I'm not going to show that because I don't know if it's something sensitive. Then we get the output. We look for that basically, the IO platform UUID. I think that's a device. So like the disk UID maybe. So it might not be, if you replace your disk, you'll have to re-register your device. Gonna have to think about scenarios like that. But this is mostly for my usage. So basically we get that bit of information, we extract the UUID out of it, and we return the UUID. So that's our identifier and the model, and that's basically just us setting everything. At this point, we have a device good to go. So that is as far as I've got with the code so far. This won't work cross-platform right now. At the minute, it's aimed at Macs right now. Because that's what I use. However, it will all be open source. So people are able to contribute to it. I haven't pushed the code up yet, but I'm going to push it up after this stream. So if you do want to add a PR, feel free to add a PR. The code's not working 100% yet, as I said. So, if I go run main.go init, great, that works. I run config, 1, 2, 3, failed to write to file, blah, blah, blah. I haven't gotten over a few of the bugs yet. So, go run main.go, register for the device. We want to register the device, cannot send an authorized request. Haven't set the API key yet. So things are working. So when we register, what we're going to do is register command down here. HTTP client, going to do that. We're going to get this device setup, get the device and send it basically, get the conf key, send it to that URL. What this is going to do eventually is basically just run within a Go routine as well. So it will run within a Go routine. I might pass it off to something else, have like a sync and a wait group and things going on. Haven't figured all of the details out, but I'm going to get to that. Maybe not tomorrow, but the day after. Tomorrow, I'm going to come back to this API, finish out parts of the API. This is probably a project that's going to be long term. So I will probably do this over a period of weeks, mixing in other content so people don't get bored of watching me struggle with Go. But that's the plan. We've got some PHP here, some Golang here, and there's this API in the middle, which is perfectly depicted by my lovely graph here, which shows I've got my laptop, my desktop, and Envy. And then Envy here, this will be built up of a CLI a CLI over here, and API over here. There may eventually be some sort of kind of, thin front end, just to, maybe you want to kind of manage it, work with it. I don't know, but there might be something like that eventually. That part there is, a bit of a question mark right now. So I'm just going to color that red because not that bit. This bit red. There we go. That bit I'm not too sure about. We'll get around to that perhaps. But right now we're focusing on the CLI and the API so that I can get all of my homebrew packages, all of my Mac apps, all of my kind of editor configs synced from one device to another really easily without having to go, okay, brew update here, pull down my latest dot files, make sure I've got everything installed, brew cask, it starts to get quite cumbersome to keep your environments up to date, on Mac specifically. There might be an easier way to do this, I'm not sure, but I thought it would be a fun little project to do. It gives me a chance to build an API and a cool CLI tool, which is always fun. So that is the end of today's stream. Again, thank you for joining me. Means a lot. Always like it when people join me. Makes me feel like I know what I'm doing. And if not, it's just fun to chat and code. Join me again same time tomorrow, where we're going to probably work more on the API to try and get a bit more fleshed out, ready to then work on the CLI on Thursday. Likelihood is it'll be this again next week, but hopefully we'd have got more of the API done so we can then focus on a few episodes of doing the CLI. I'm assuming a lot of people are here to see what we can do with like Golang as well with Laravel API, because they both work really well together. And thank you for tuning in regularly. Remember to like, drop a comment if you got any good feedback for me. I always appreciate good feedback. I'm always trying to make out my streams that little bit better. And subscribe to be notified for the next one. I noticed my signal's dropping a little bit, so I will call it there and say thank you very much. Have a good day, good evening, good morning, whatever time it is. Stay awesome, and thank you.